Hello, my name's Frank, and I'm teaching today quadratic applications. I hope you're all well and hope you're ready to learn. Um, in the past, you've studied quadratic equations. You have learned how to solve quadratics of the form ax squared plus bx plus c equals 0, of course, when a is non-zero. That makes it a quadratic. And you hopefully have explored graphs of quadratics of the form y equal ax squared plus bx plus c. A is non-zero. Today we're going to learn how to apply this to some situations. So I have 3 examples for you today. So we're going to go step by step and work through them, all right? Okay, so let's start on the first one. Okay, here is the first problem. I've drawn a rectangle for you. Of course, you have 4 right angles. And the question is, the length of the rectangle, which we'll call this the length, L, is twice the width, which we'll call W. So the length is twice the width. The question is, the area is 200 inches squared. So you are asked to find the length and the width as a number and also the perimeter. So let's go ahead and do that. All right, we know that the area of a rectangle is length times width, but that it has 2 variables, L times W. We need to use this. The length is twice the width. So how we do that is we model it. So in that case, we have length is twice the width. Twice means 2 times. So length is twice the width. Now the formula for the area of a rectangle's area is length times width. So to get this in terms of one variable, what we do is we know the area is 200. So we have 200. Now the length is twice the width. And that was given. So what we do is in place of L, we write 2W. So we have L becomes 2W times W. So now we have an equation in one variable of W. So we have 200, 2W times 1W is 2W squared. And there we go, we have a quadratic equation, exponent of 2. So numerous ways to solve it. You could factor. You could use quadratic formula, but in this case I think I'm going to use square roots. I believe it's the quicker. So what we do is we divide by 2, and this becomes 100. And these 2's divide out, and we have W squared. Okay? Now, to get rid of the W squared, we take the square root of both sides. So we have the square root of 100 is equal to W. Now, in this case, we know it's going to be 2 answers to this. You're going to get plus or minus 10. However, you cannot have a negative width. So the answer to this problem is the width is 10. So what we discovered here is the width is 10, and the length is 2 times 10, which is 20. Now let's check that. 2 times 10 is 20, we got that. And what's 20 times 10? We have an area of 200. So it worked out. So in answering this, let's get our questions. Our first is the length. Well, the length would be 20 inches. Remember your units of measure. Your width would be 10 inches. And to check this, 20 inches times 10 inches is your 200 square inches. And then the last question is perimeter. Remember, perimeter in a rectangle, opposite sides are the same. So if this is 20, this top's 20, the bottom's 20. If the right's 10, the left's 10. So the perimeter is the distance around it. So we have 10 plus 20 plus another 10 plus another 20, which is 60. The perimeter is 60 inches. So hopefully you understand this, and that's our first example of how we can use quadratics to solve applications. Okay? Let's shift to our second example. Okay. The second example is one that's a verbal expression. The product means multiplication. The product of two consecutive positive. For example, if 5's one positive integer, the next one right after it is 6. If 10's one, the one right after it's 11. So they got to be right after each other. The product of two consecutive positive integers is 72. Find the two integers, and then find the sum of the two integers. Okay, so what are the two integers? Okay, what we're going to do is identify the integers as a variable. You can take your choice. You can use n, x, what have you. I will choose x. Let x equal the first integer. It's always good to identify in verbal writing what your variables are. That way we can go back and refer to it. X is your first. Now, if 6 is your first integer, 7 is your second. How do you go from 6 to 7? You add 1. 6 plus 1, 7. So how do we go to the one right after x? We add 1. So we have two integers. X is the first one, and x plus 1 is the second one. Now, the word is product. So we're going to multiply them two. And we're going to set it equal to 72. Okay, now we're going to work on solving this. We're going to distribute the x, and that leaves us x squared plus x is 72. Okay, now we're going to move back a little bit, or move to the right a little bit, and we're going to put this in standard form by subtracting 72 from both sides. So let's rewrite it. And subtracting 72 from both sides, we have negative 72 and negative 72. X squared plus x minus 72 is 0. Now, solving this quadratic, we're going to use factoring. There's two multiples of 72, which hopefully will jump out at you fairly quick. You can factor that as x plus 9 and x minus 8 equals 0. Now, Looking at these two numbers, factors, we conclude there's two x values that will work here. One is x could equal -9. But we can't have x to be -9 because the question said they were positive integers. So it works out mathematically, it just doesn't fit the conditions of the problem. So we don't want that one. The second one says x would have to equal 8, which is positive. That's our answer, 8. So now the beauty of this, you come back and you identify the two integers. X is 8, and x plus 1 is 9. So now we have our answers. Our two positive integers are 8 and 9, and the sum of our two integers is 8 plus 9, or 17. So there you go. Okay? Read the question, identify your variables. Set up your equation, and then solve it by a means that you've learned. Okay? So this is our second example. Now we go to example 3, and that's over here. The sum of a positive integer and its square, the square of that integer, is 72. Sort of like the previous problem. But now we don't have consecutive, we have a number and it's squared. So let's identify the variables. Let x be the integer. Okay. And that's the only one we had, the sum of a positive integer, and it's positive. So let's write the equation, step 2. The sum of an integer and its squared is 72. Very like the first one, or second example. So here we are, we got the equation set up. Now, we put it in standard form. And I would encourage you to factor with the highest exponent first. That's called descending order. It makes it easier. You put your x squared first, plus your x, minus your 72. And you can see now that just like the second example, we then factor this. We have our two x's. That sign says one's plus and one's minus. And we have plus 9 and minus 8. So we look at this and we have the same factors as we had in example 2. So we have x to be -9, but it can't be -9 because it's a positive integer. So we reject it, and then x would equal 8, which is positive. We take it. So we have two integers that we worked out mathematically. One doesn't fit the question, the other's 8. Now let's check our answer. The sum of a positive integer, we found that to be 8, and its square. Is that 72? Let's see. 8 plus 64, is that 72? And we find out it is. So we have 72 is equal to 72. So our answer to this question is x equal 8. Right, this is the beginning of solving quadratics in applications, and we'll continue on the next version where we will make them a little bit more complex. But I hope you found this informative, and I look forward to seeing you next time. Thank you.